Hello out there, thank you for checking out my video today on an introduction to complex numbers. So first of all, let's talk about what a complex number is. Before we can really do that, let's talk about what an imaginary number is. Okay, so just reading along in this paragraph here, for a long time, square rooting a negative number was considered impossible. After all, what value multiplied by itself could possibly be negative? However, mathematicians proposed that there must be some way to perform these operations, and eventually developed an imaginary number I. The name was given as a joke, after all, because a number is not real, it has to be imaginary. Many mathematicians did not accept I at first, but it has since been used and accepted in many branches of math and has some real-world applications as well. So first of all, what is the imaginary number? I is equal to the square root of negative 1. All right, so up until this point, when we took the square root of negative, we would say that's not possible. And you're right, it isn't possible in the real number system, in the real world. Okay, but in the imaginary number system or the complex number system, it is. So what is a complex number? A complex number has a real part and an imaginary part. Okay, we have something called the conjugate of that, where all we do is we change the sign of the complex number. So a minus bi would be the conjugate of a plus bi. So let's start with some simplifying of each of these. So the square root of 1 would be 1, but the square root of negative 1, we already just talked about that, is I. Number 2, we could break this up into the square root of negative 1 times the square root of 25. We know this is I, we know this is 5, so this is plus or minus 5I. Technically this is plus or minus I as well. Number 3, we can write this as root negative 1 times root 5. So this would be plus or minus I root 5. We don't really know what the square root of 5 is, so it's just root 5. And then finally root 40. So we get negative 1 times root 40. We know this is I. Root 40, we could break that down into root 4 times root 10. So this would be 2, and then this would be I, so we have 2I, and then root 10, plus or minus 2I root 10. Next, let's talk about the powers of I. So we just learned that I is the square root of negative 1. So I squared would be root negative 1 squared. When you square root a square, or square a square root, you get the inside, which is negative 1. So I squared is negative 1. I cubed would be I squared times I, which is negative 1 times root negative 1, or just negative root negative 1. I to the fourth is I squared times I squared, or negative 1 times negative 1, which is 1. If we keep going here, I to the fifth would be I to the fourth times I, which is 1 times root negative 1, or just root negative 1, or just I. I to the sixth would be I to the fourth times I squared, so that's 1 times negative 1, or negative 1. I to the seventh would be I to the fourth times I to the third, so it would be 1 times negative root negative 1, or just negative root negative 1. Or we could also call that just negative I. I to the eighth would be I to the fourth times I to the fourth, which is 1 times 1, or 1. So hopefully you're starting to see a pattern developing here, and it's going to keep going like that. Okay? So I to the ninth is going to be equivalent to I, which is just root negative 1. I to the 10th is going to be the equivalent of negative 1, I squared. I to the 11th is going to be negative I, or negative root negative 1, and I to the 12th will be 1. And this is the pattern it'll continue on every four numbers forever. So if we did I to the 16th, since that's 4 more than this, that would also be 1. I to the 17th is 1 more than that, so it would be I. I to the 18th is 1 more than that, so it would be negative 1. And I to the 20th is another multiple of 4 here, so that would be 1 again. So what is the rule for finding I to the n? Basically, you want to see the exponent, how much more it is over any multiple of 4. Okay, so you want to divide n by 4, and whatever that remainder is, it's going to match up with one of these. So let's take a look at a couple. I to the 30th. If we divide 30th by 4, we would get 7. So that'd be 28, right? Because we can break this up into I to the 28th times I squared. This would be 1. This would be negative 1. So our answer is negative 1. I to the 51st. We know I to the 48th would be 1. So it's I to the 48th times I cubed. So this is just going to be I cubed or negative I. All right, and the last one here, I to the 20th, we know that is 1. That's a multiple of 4. And then root negative 4 is going to be plus or minus 2i. So our answer here is just 1 times plus or minus 2i, or plus or minus 2i. We can also perform operations with complex numbers. We can add them, subtract them, multiply, and divide them. When you add or subtract complex numbers, you want to add and subtract the real parts and add or subtract the complex parts. So 4 plus 2 is 6. Negative 3 plus 7 is 4, so 6 plus 4i. B, if we distribute, we get this. So 6 minus 6 is 0. Negative 18i plus 2i is negative 16i. C, if we distribute here, we get 6i plus 10i squared. We know this is negative 1, so 6i minus 10 would be our answer for C. D, 3 plus 2i squared. So 3 times 3 is 9. 3 times 2i is 6i, so that'd be 12i. And 2i plus 2i times 2i is 4i squared. You know, this is negative 1, so this becomes negative 4. So it's 9 plus 12i minus 4, or 5 plus 12i. Distributing here, we get 25 plus 10i minus 10i cancels, so minus 4i squared becomes 25 plus 4, or 29. A plus bi squared would be a squared plus 2abi plus b squared I squared. This again is negative 1, so I can write this as a squared plus 2abi minus b squared. E, multiplying this out, we would get a squared plus aib minus aib cancels, minus bi squared. So it's going to be a squared plus b squared. F, simplifying this is a little bit different. So we haven't seen one like this yet. What we have to do is we have to multiply by 1 to simplify this, but not just any form of 1. It has to be by the conjugate of the denominator over itself. So that's 1. So in the numerator, if we multiply that out, we would get 6i plus 3i squared. The denominator, if we multiply that out, we would get 4 plus 2i minus I squared. So if we simplify this, we would get 6i minus 3 over 4 minus negative 1, or 4 plus 1. So it's 6i minus 3 over 5. And we can rewrite that as negative 3/5 plus 6/5 I. Same thing on G. We're going to multiply by the conjugate, negative 2i over itself. So it's negative 10i over negative 4i squared, which would be negative 10i over 4, or negative 5 halves I. Okay, if you remember this from back in the first day, this is our real number system. Okay, but there's also over here the complex numbers, right? So we're going to try the same problem 3 different times here. We're going to factor this over the real number system. So what do I mean by that? I mean we're going to factor it until we no longer have rational numbers available. I said real, I meant rational. So we're going to factor by grouping. Take out an x to the 4th. We're left with x squared minus 2. Take out a negative 16. We're left with x squared minus 2. Perfect. That gives me x to the 4th minus 16, x squared minus 2. Can I factor this into rationals? Yes, I can. Can I factor this into rationals? No, I can't. So this part here is done. For the first part, I can factor to x squared minus 4, x squared plus 4. Can I factor this more? I sure can. Can I factor this more in rationals? No, I cannot. So this part is done as well. But finally, I can do x plus 2, x minus 2 times those other two factors. And that is how we'd factor this in the rational real number system. The next problem is exactly the same thing, except now we're doing all real numbers. So you can copy and paste this from above. It's the same exact problem, and we are where we were at the end of that last problem, okay? But now it just says factor over the real number system, so they don't have to be rational anymore. As long as they're real, it's okay. Can we factor this in the real number system? No, we cannot. Can we factor this in the real numbers? Yes, we can. So these 3 are going to stay the same, and we can factor this one a little bit further. So x plus 2, x minus 2, x squared plus 4 all stays the same. But now this can factor to x plus root 2, x minus root 2. And that is how we would factor it in the real number system. One more, now we're going to factor it in the complex number system. So we're going to take everything we just did and see if we can go one step further. All right, so again, if you want to copy and paste from above, you're welcome to do so. We're here. We can't factor either of these any further. We can't factor any of these any further, but this one we now know we can factor in the complex number system. So copy down these first 2 factors, copy down these last 2 factors, and now we can factor x squared plus 4 to x plus 2i, x minus 2i. And this would be completely factored in the complex number system. All right, so now what we're going to do is a little bit of practice solving each equation over the complex number system. There's 3 problems here. If you feel confident and you want to try these 3 on your own, you're welcome to do so. You're just factoring like we did here and then setting each piece equal to 0. Okay? If not, I will go through them one by one in about 5 seconds here. But if you want to try these, pause the video and try them now. So this first one, this is one way to do it. You can just subtract the 4 over and take the square root. Okay, the other way you could do it is, now that we know how to do this, we could factor this to x plus 2i, x minus 2i, set each piece equal to 0, and we'll get the same answers of plus or minus 2i. The second one, we're going to start by bringing the 16 over and then factoring it in the real number system, and then setting each piece equal to 0. Now you could keep factoring both these if you want, or you can use square root method like I used here. So add 4, subtract 4, take the square roots, and those are your 4 answers. Or like I said, you could go back to this slide and continue factoring in the complex number system. Last one, we want to factor this one. So we're going to factor it in the complex number system. This is the real system first. And then you can either set both equal to 0, or you continue factoring this to x plus 3i, x minus 3i, x plus 2i, x minus 2i. Either way, you should end up with these as your final answers. All right, I will leave this slide here at the end. If you want to pause this video and take a look at this any further, you're welcome to do so. Otherwise, thank you as always for tuning in the video today.